this. So we'll do start. Okay, I just want to start by sharing three, right? I saw three, right? You can see you can see the Google Sheet and everything. All right, cool. So I was looking at the Google Sheet about where we're at in regards to the topics that we've covered. Um, we are going to talk about chapter 23, hierarchical data today. You'll notice that we have web scraping next, which will be done on next week. But I did want to highlight as a reminder, because as the facilitator of these sessions, John the Geek, who is the director of the data science learning community, has pushed out a few messages to different areas within the Slack as a reminder that the DSLC takes kind of like what's called spring break. It's mainly because of the time change. So um, obviously throughout the world, daylight savings time is different. And so it gets really challenging to try and manage the back end of how this all works, especially because the DSLC is a global community. And so just to manage that and to make it easier for John to manage these book clubs after web scraping, we will take the 13th, 20th, and 27th off, but we will look to return on the 3rd with functions. And so again, the reason for that kind of 3-week break is because of daylight savings time. It just messes things up. Other parts of the world change at different times, and it just messes up the scheduling for some of these sessions. So just want to highlight that, especially for people who might be watching this later, looking for us to join. We will take that 3-week break. I do also want to highlight that looking at this, we only have 6 more chapters to go, which is
Yeah.
about a month and a half worth of stuff. So we are really close to finishing this book. And so hopefully when we get back in April,
Yeah.
we'll smash out the rest of these. So
Yeah.
really excited about it. Cool. Yeah. So then if anybody wants to take web scraping, like DJ, if you want to take web scraping, you sure can. But if
Yeah.
anybody's watching this later, feel free to jump in and talk about this. So that's housekeeping stuff. Let's start talking a little bit about our topic today. So we are going to be discussing chapter 23, hierarchical data. I thought this was a really interesting chapter. It took me a second to better understand the structure of hierarchical data, especially as they relate to list columns. And so how to actually work with them was kind of a fun little exercise because in the past, especially in my experience, when I came across a list column, it was challenging and struggling for me to solve. So we'll cover that today. Just like we discussed the format of this specific cohorts going through the book, we're not going to go step by step, but rather we're going to open it up for key points that people want to highlight, open it up for any further discussion of complicated topics. And then the last part will be going through the exercises step by step. And so, yeah, so that's what we'll cover today. And that's more of the formality of it. But DJ, it's just you and I today, unless we pick up anybody later on. So we can just kind of have a more of a conversation as we go through it. So, I don't know. So I'll open it up for you, DJ, before I highlight my key points. Was there anything in here that you wanted to highlight or that you found challenging that we want to dig into more?
Maybe unnesting. I've seen that's that topic only. Uh,
Yeah, the unnesting was really important. I think we can dig into that a little bit deeper. Absolutely,
yeah.
that was one thing that I highlighted. Um, so yeah, let's talk about it and then we can cover some additional points that you have. So my takeaway with the use of unnest longer and unnest wider, first off, these are functions that are part of the tidyr package, right? And um, so if you're not familiar, this is the package that these functions come from. Um, what I really took away from this was the use cases to where these get used. And it really comes down to, at least when I was reading this, understanding what type of list you have. Do you have an unnamed list or do you have a named list? Because generally, an unnamed list, to transform it into a data frame, you would use unnest longer because it would take it and turn each of these elements into rows. Wait, yes, longer, because then it would apply those into rows. If they are named, you'll put it into using unnest wider. And so I think that was a really important point that was discussed in here, was understanding and identifying. And that's what really helped me in the exercises, was first asking the question, what type of list do I have? Do I have an unnamed list or do I have a named list? And identifying that led me to, okay, do I need to unnest wider or unnest longer?
Yeah.
Now, there were a couple like edge cases where that kind of general rule didn't apply, especially in the exercises. But that's like my takeaway of where these get applied. Is just really understanding what type of list you have and that list dictating which one you use. So
Yeah.
did that clear that up, or is there anything else that was unclear about that?
No, actually, yeah, I was trying to see like a few examples of that unnesting exercises. So yeah, but we can go through in the next. Yeah.
Yeah, we'll definitely talk about them in the exercises because we
Yeah.
use them a lot, but those are basically the tools. But I mean, I like one thing that I wanted to highlight that I thought was really interesting as well was like how do you actually look at the list? Like when you print a list, depending on how complex it is, it might be easier to use str or structure because it has a better print method for a list. It summarizes it rather than like printing all of it. And I even made the mistake of trying to like print out the list for like the GitHub repos exercises. And it was just like, I mean, it wasn't too much, but like because it was only like initially like 6 rows, but then like once it expands, it like just prints a ton to your console or to your to your console. So I really found that just to look at to see what type of list you have, use str. It was really helpful, and I used it a few times in the exercises to show that that was great to kind of show it. Um, then I guess the other highlight that I had before we start digging into the exercises was the discussion about JSON data, and we'll talk about that as we get to the discussion or the exercise a little bit more. But it was really nice to have this like really simplified explanation about the structure of JSON, you know, what types of values does it take? What
Yeah.
are the other types of ways to contain values? And I thought that was a really good summarization of like the structure of JSON. At least in my mind, I don't deal with a lot of JSON. And so outside of like maybe like a web API, but it's nice to kind of have this like further explanation and to have like the analogy between like some of the elements that you see in JSON are, directly relate to the structure of a list. There's just only some like minor differences, which I thought was really, really interesting. So,
Yeah.
um, anything else? Anything else you want to talk about
Mm.
or highlight before we get into the exercises?
No.
No, cool. All right, cool. Well, let's dig into some of these here. So I think we can get through all of them. Um, we could sure try to get through all of them here. And can you see these, or do I need to bump them up a little
Yeah.
bit? I can probably bump them up just a
Oh
little
yeah,
bit.
that works. Yeah.
Okay, so let me see if I can scroll this over. Okay, so the first set of exercises, um, this one talks about like what happens when you use unnest wider with unnamed list columns like df2. So here's df2. Here's the example. Oh, I actually got to run this, so let me run it so I get caught up. So let's look at df2 here real quick. So here's df2. Obviously, we have a list column here. list column with 3 different elements, an unnamed list column.
Yeah.
And so it's basically asking, okay, well, what happens when we run unlist wider on it? Here's the structure of it. So if you want to see like what elements are in it, it just contains like numbers. One has 3 numbers, one has 1 number, one has 2 numbers. If you try and run unlist wider, you get an error. And basically the error is telling you that you can't unnest elements with missing names. So this is a good like catch-all and a reminder that unnest wider requires a named list. But what you can do is um, you can supply a value to this names separated argument, and it will replace it. And so what you do is when you run this, it'll actually run it. And so it will do like a y1 value 1, y2 value 3. And then what happens to missing values? Because technically when we do this and expand it, we will have missing values that get introduced. They get converted to NAs is what happens. So
Yeah.
it was just an emphasis of names separated. So if you do have a list column that's unnamed, in this case, you can use unnest wider. However, you need to use the name sep argument to make sure that you apply to say like, hey, it came from the Y column, but for you to expand it into its own additional columns, you have to give it, a separation, go Y1, Y2, and Y3. So, make sense?
Yeah.
All right, cool. This one was pretty straightforward. It just took a little bit of digging into the documentation and playing around with it a little bit. So, what happens when you use unnest longer with a named list columns like df1? What additional information do you get in the output? So let's just look at this here real quick. Let's just look at df1 again. So here's df1. We obviously have a list column, an unnamed list column.
Yeah.
So we would think that we would use unnest wider, but it's
Yes.
going to ask us to just try and see what happens when we use unnest longer. So if you do this, what it will do is it will create an ID column, right? So if you look at df1, it will create an ID column for those different elements. So you have AB, AB, AB. So it just automatically creates an ID so you know where this element came from. If you don't want that, you can supply a false to indices include, and it will exclude that ID column. So I guess what this is like getting at and highlighting is like, yes, the main general concept is like, if you have an unnamed list, use unnest longer. If you have a named list, use unnest wider. But you can use those interchangeably, but you just have to rely on some of the arguments to change the actual output. So is I think what it's trying to get at here. It's like you can use it for any wrangling task that you have, whether it's a named list or an unnamed list. But for you to get what you expect, you would have to use, well, one, to actually get a values returned, you'd have to, in this case, use the argument. In this case, if you didn't want the ID column, you have to exclude it. So,
Yeah.
any questions about this one?
No.
All right, cool. Okay, so this next one. So from time to time, you encounter data frames with multiple list columns with aligned values. For example, in the following data frame, the values of Y and Z are aligned. Y and Z will always have the same length within a row. And the first value of Y corresponds to the first value of Z. What happens if you apply 2 unnest longer calls to this data frame? How can you preserve the relationship between X and Y? And then the hint was carefully read the docs. So this took me a second to understand what was going on here. So the first thing I did was I obviously created DF4. I looked at DF4. Which then we have 2 list columns, and they are containing unnamed lists. So I just really quickly like pulled them out to see them, like what they look like. So did this like pull Z, pull out the column, run a structure on it so I could kind of see what it was doing and what it looks like. Now, if you just run this where you do an unnest longer Y, then unnest longer Z, you technically get the Cartesian product. So all the combinations for all the nested variables.
Yeah.
And this may not be what we want. And so to preserve, and I can't remember the exact language they use, I think it said to preserve. So they're aligned columns, the same length and row corresponds to Z. What happens if I? Yeah, how can you preserve the relationship between X and Y?
Yeah.
And so to do this, you need to pass in a concatenated Y and Z. So you do unnest longer for both Y and Z. And then when you do this, it maintains the relationship between Y and Z. So you have all the Y values, YA1, YA2, and then Z, ZAI, rather than creating the Cartesian product.
Yeah.
So this took me a little bit to understand what was happening because the data structure was kind of weird when you first look at it, but it's just important to remember that all these elements here, so for A, Y, Y, B, Y, Y, and then A, Z, Z, B, Z, Z. So it was kind of hard to like wrap my head around what was going on at first,
Yeah.
but it just goes back to that idea of like, if we look at the structure of them, we have, so DF4, look at DF4. We have technically in Y and Z an unnamed list. And so longer would be the natural thing to do. But if we did two, it's going to create the Cartesian product. However, if we unnest longer and then just concatenate both of them, it will maintain that relationship of having individual Y and Z columns without like doing the cross product of them. So
Yeah.
a little bit of a little bit of a like brain teaser here. But I did look and see this exact example is in the unnest longer function. So it expressly states like if you do want to maintain relationship between aligned columns, you just pass it in like this. So that's in the docs. I can show you. So let's just see. Unnest longer. It's all the way at the end right here. So this is important because sequential unnesting would result in the Cartesian product of the rows. So explicitly stated right in the examples of what happens. All right, cool. Any questions about these ones?
No.
No, these ones are pretty straightforward.
Yeah.
Let's move on to the next one here. That's D4. Okay, so this is the next section, and this was like the case studies one. Um, so first off, this question was roughly estimate when GitHub repos was created. Why can you only roughly estimate the date? Okay. Um, so I started off with the repos thing because this was our tibble with our list column. We first have an unnest list, an unnamed list. So then I did unnest longer, which then results in, if you run this, repos, unnest longer JSON, you get another list column
Okay.
with unnamed list with 68 elements. So you unnest wider. Wait, is that wider? Wait a minute. Why did I do wider in this case? Did I do this right? That's right. List. Or were these actually named? Hold up. I might have done something wrong. I don't think I did, but I'm just going to double check.
Yeah.
So I'm going to glimpse it real quick just to see. I also thought glimpse was pretty helpful as well
Yeah.
to kind of look at it. That's not true. Is this where I did too much? Oh, JSON. JSON. This might actually explode my console, but let's just see. Print. No, pull JSON. JSON. Stir. Stir. Why did I do wider here? Remember? Yeah. Why did I do wider here? It's unnamed. Is it a named JSON? Or is it a named list? Pull. Let's see. I'm just gonna run this again. Repos. So if I do this, why did I do on that's wider in this case? This is unnamed. Why am I not? Oh, because this is a list 30. Why did I have this here? Because this, in my mind, I thought I would go unnest longer because it's a non-named list, but for some reason I have unnest wider. I think this is actually how it was. List ask. No, anyways, I can't. Not exactly sure why I did unnest wider here because I would think that if I did this,
Okay.
it would be an unnamed list because it's
Yeah.
not named. But it must be something from the examples that I picked up to do wider because then next they would have the name list. And so then I
Yeah.
would select these items here. And if you take a moment to kind of like dig through the names, which you could easily do it this way, you could do like names like this,
Yeah.
and you can look at the names. You'll notice that in this data set, there's I already selected it, but
Yeah. Exactly.
there's an updated date. I think you get the point here, but like, oh no. Um, updated at uh, names. So let's go here, run this, look at it. Oh, why is this not working now?
I think it's call name, I think so.
Say what?
COL. It's a column names, right? Like COL names, function name.
What is going on? For some reason. Okay, say that again.
I think the function name is like call names, like a COL names, I think so.
Yeah,
Or
you can use CLL, but names work. I don't know why it did that weird rendering, but um you could parse through this and you can kind of see all the names of the different columns that are in this. And there's a one called updated date somewhere. So last updated or something, created at, updated
yeah,
at.
yeah,
And then in my mind, I said, okay, let's make this simpler. Let's do select the columns to make it easier to read.
yeah,
ID, full name, updated at, created at. Let's arrange by the updated at column, make it biggest to smallest, slice the first one, and just pull the updated at, and then this is the date we get. And my answer was the reason why this is approximate is because this is the last date that the last updated repo date. So that gives us a sense of like when the data was pulled from the API, but it doesn't necessarily give us a sense of when the actual GH repo data set was created because we don't have a data point for that. But we at least know that it was created sometime after 2016, 10, 25. I don't know. Did you have another answer for this?
uh, what does like created at shows like created at which date it
Um,
created?
that's a great question. Well, maintain this. Let's do this. Because I thought about that too when I did created at. Oh, I did created at. From this.
You need to put like replace a pull.
Which one?
full
Oh, yeah, you're right. You're right. You're right. Create apps. Good call. Oh, what is going on?
I got a factor of this session was done.
I don't know why my R Studio is just causing me so many problems today. Okay, well, anyways, let's redo this.
Yeah.
I don't know. Maybe I have to update my R Studio, which could be the problem. I'm just been having some issues with it recently, which is probably the case. I need to update it. So then it would be the 24th if you did the created at date. So
So it's
this
asking
is
for
the
right?
say what?
It's asking for a created date, right? The GitHub repos.
Yeah, but I think the question was why can you only okay, so roughly SO was created no, when GH repos
Yeah.
was created. So I thought it was the data object, not the repo. It's because this is a collection of 6 users repos up to 30 repos per user.
Yeah.
And so and that gets confirmed because some of these people have so each one of these would be like a person
Mhm.
and these 3 people have 30 repos, this person only has 26, these two have 30.
Yeah.
So I think like the created at date without me digging into like the API docs and whatever would be like when that specific repo was created by that person. But if I think about the question, it's saying like when was GH repos, the actual data set created,
Yeah.
which is because repos is just the Tibble version with a list column
Yeah.
of the GH repos. I'm scrolling you to death here. Let me find it. Let me just find it. Because GH repos right here, we just turn it into a Tibble, pass in GH repos to turn it
Yeah.
into a list column within a Tibble. So that makes sense. Okay, cool. Um, rectangle. Okay, that one was a little tricky. I mean, at least that's what I think it's trying to get at, but I mean, I could be wrong. Um, but that was my assumption, and that's what I wrote about it. Okay, so sticking with GH repo here, um, the owner column of GH repo contains a lot of duplicated information because each owner can have many repos. Can you construct an owner's data frame that contains one row for each owner? And the question was, can you use distinct with list columns and does it work? And so I use this package called Waldo to compare. Oh, I cannot run my computer today for some reason. So I use this package right here to make comparisons. Because the first thing I did was I did all this on nesting. I took out the owner and then I just
Yeah.
looked at owner to see what it is. So actually, let's just go here to here. So owner is I'm missing here. Unnest.
I think it's not unique. Just all the owners, even they have like a multiple.
Yeah, but what's throwing me off is like so what's throwing me off is the print here inside of okay, you see the difference here? So this is actually really throwing me off, and I don't know if this is a bug that we just found. So when you print here
Mm.
inside of a notebook, the list column gets represented as this.
Yeah.
But when you do it in your console, it represents it as a named list.
Mhm. Yeah. 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 Yeah.
I don't know if this is a bug or not, or if this is just an issue because I haven't updated my RStudio recently. But that was why I was confused of why we do this on nest wider is because I knew it was a named list. Like that, let me just take this. Right, that's a named list. It's just not printing correctly in my notebook. Yeah,
Yeah.
it's not printing correctly in my notebook. Okay. Um, I don't know if I found a bug or if this is just an issue because of how I haven't updated in a while, but I can show you how to change the setting. So if you want your chunk output to be inside of your code, you can select this, but if you want it to be console, you can select this. And then now if you run your code chunks here, it should just only output it to your console rather than the actual thing itself, and it does.
Yeah.
Wow, okay, so I don't know if I just found a bug or if this is an
Yeah.
issue of me not updating our studio as of recent. So, um, okay, cool. So we get here, we have the name list. Put this up so you can kind of see it a little bit more. Here's the name list. Um, because we have a named list, we have to do an unnest wider. And then at this case, I was like, oh, just distinct it. Like this was my first attempt. So just distinct it. Boom. And then it just now you can see you have, because the initial thing is for 6 people, you have now a tibble with 6 people represented in it. So that distinct works in this case. Um, but the book was like, hey, does distinct actually work before you do unnest wider? And so I tried it and I'll run it. Create this where distinct becomes before we go to the wider portion. So we can just run this up to here so you see it. So now we have a named list with 6 elements. And if we unnest this list to wider, you can see that it actually works. And just so to confirm it, I'm going to use this function from Waldo called compare. And it should return to say there are no differences. So they are the exact same data object. So to answer the question, yes, distinct does work on a list column if you
Yeah.
have repeated values, which is kind of neat. It's a nice little trick to like help simplify things a little bit more. Cool. Any questions about this one?
That makes sense actually. Yeah.
Yeah, it's pretty cool. It's kind of cool that distinct works on list columns,
Yeah.
which is very helpful because I'm sure there are times when you have a list column that just has a bunch of repeated values within it. And so if you just need those unique values, you can distinct it right away. Um,
So you don't need to use like a unique, unless wider, right? Because it's already named.
yeah, so let's see. So up to this point, up to owner.
Yeah.
Okay, so here's owner. So these are all the repos,
Yeah.
right? So these are all the repos. And actually, it might be hard to see because I only selected one column.
Yeah.
Maybe if we do ID, would ID be for the repo or the person? I think it's for the repo. Yeah. Okay. And actually, is there like a name in here too? Names. Let's just check. So I think there's like a repo name, but you can like a short name or something. Yeah,
I,
a name. Oh, go ahead. Go ahead.
no, no, that's all right.
So we got that. Let's take select. Let's take that out. That here. So then here we run this. So here you have, and actually maybe we should put owner in here too, because then that would make sense because you would have ID, name of the repo. Oh, you do have owner. So yeah, because then you have all these owner elements,
Yeah.
right? So you have all these elements related to the owner of this repo. And so if you unnest wider here, like I do initially, unnest because it's a named list,
Yeah.
right? Unnest wider because we want to take those named elements and turn them into their own columns. Unnest wider. Run this. Oh, we got to specify which column we want to expand. Run nest. So now, oops, nest wider. What I do? Select owner. Oh, did I have to do that here? Oh, I didn't. Okay, so now I have a problem with the naming convention. So now I have to do name sep because it's telling me can't duplicate names. Oh yeah, because yeah, so I have to do like name sep, names sep equals no, that's the sep character. So you have to give it this. So let's look at it here. Because then you have like things like the owner login, the owner ID. Oh, oh, I can see how the ID is going to mess up with this because you would probably have a user ID and you'd
Yeah.
have a repo ID. So that's why you have to use name sep. But like um, owner login, owner ID, owner da da da. This is just unique to the actual owner itself, and it just gets repeated. So you could just distinct this table to get the owner information of that repo in a condensed file, is the way I understand it. Does that clear this up?
Yeah.
Okay. I'm gonna sit down. I'm standing right now, so just give me a second. What other questions do you have about that?
No, I got it. Like using that name separator. Yeah.
Yeah, it's just it's just kind of nice to know that distinct works in this case. You don't have to like you don't have to you don't have to like unnest it first to distinct it. You can distinct it before you do that, which is
Yeah.
really kind of nice. So distinct works on list columns. Okay. Um, this one, follow the steps used for titles to create similar tables for the aliases, allegiance, books, and series for the GOT characters data set. So are you familiar with Game of Thrones?
I didn't watch. I watched few episodes, but it's very long, so I didn't watch.
Oh, TJ, you're missing out. You're missing
Yeah,
out.
because I don't want to like spend that much like dedicated time again for the series, and it's very long. I cannot finish in like a month or like 2 months.
Oh, yeah, we could, but you would spend I don't know, maybe take some time to watch it because I thought it was really good. Um, yeah, take some time to watch it if you
Yeah.
get a chance. You don't have to smash it in 1 month or anything like that. Like, well, that would be a lot.
Kind of person like, and if I see like anything interesting, like my mind will be like thinking about that like what's happening in the next chapter or something like that. Yeah. But I need to watch actually. Maybe Spring Break, something like that. I'll
Yeah,
try.
yeah, check it out. I like it a lot. Okay, so yeah, check it out if you get a chance. But anyways, we'll look at a couple of these. I don't think we need to look at all of these. But the first thing that I did was again, we have this tibble with a list column, named lists, column name is JSON. Because it's a name list, we're going to use unnest wider. And in this case, I'm just going to select. I could try that. Anyways, I just took it like this because these are all the list columns with the IDs. And then if I look at this object here, you can see that these are all list columns. So ID is a character ID, so a person in the show.
Yeah.
Then each one of these is like where they were in what aliases they have, like were they called by different names, who were they allegiant to, what books were they represented in, and TV series, or if they were a part of the TV series, and which ones were they. So the first one, just to unnest this, to do aliases, we can look at it real quick to make it simplified. Here, I'll ask you, instead of me just droning on, why am I using unnest longer here?
Yeah.
Why am I using unnest longer here?
Uh, yeah. Uh, because you want like another specific alias and idea, so you're selecting that and getting the data instead of like getting all the unnesting longer. You're just selecting those and you want to unnest those columns. Yeah.
Hmm. Yeah, so we're not going to add columns because longer is going to add rows.
Yeah.
But remember, it goes back to that idea of, is it a named list or is it an unnamed list? This is
It's a-
not a named list, right? So that just indicates to us that we should be using unnest longer.
yeah.
Because generally, if you have an unnamed list, it's going to represent a row.
Yeah.
But if it was a named list, we would use those names to create columns, and then we would use unnest wider.
Yeah.
So, and then I just filter, like if there's any missing, values. Did I want to do that? Yeah, I think so. That's what the example showed. But here you go. And you can see that there's some repeated values, obviously, like 1022, 1022, 1022. So, um, here's another example of using keep empty. So let's look at this here real quick. This one, we have to use this keep empty argument because some of these values are null for allegiances. So they were people that didn't, or characters that didn't have an allegiance with anybody. If we want to keep these when we unnest, we need to keep empty equals true, and then it will run. And then you can see we maintain any characters that didn't have an allegiance. So um, we can skip this one. I think we can skip this one too, but it's just basically understanding if it's a list, if it's a named list or unnamed list, and it helps you get through them. So, but for the sake of time, let's just move forward.
Yeah.
This one was interesting because it asks you to explain the following code line by line, and it basically asks you if this would work in general, um, which it does have a really interesting case. So I put a more detailed explanation in the answers here. But like just let's walk through it. So here we're just creating a list column,
Yeah.
like in a tibble called JSON. It's a named list. So that's why we use unnest wider so that we can take these named list items, create their own columns. So we'll walk through that. Um, then we're just going to select the ID column and then anywhere that they are list columns. So run this, it just simplifies it, right?
Yeah.
So we return 1, 2, 3, 4, 5, 6, 7 list columns.
Yeah.
Okay, so then this one was interesting, this pivot longer, where basically we're saying take any of these columns that are a list, so these 7 columns, put them in their own column called name, and everything that's in their value goes into value. And so I'll just run that up here. And then we unnest longer because we don't have a named list here. So we run this, look at it, and there you go. Now you have a long data set that's been unnested with all this information. Now, this isn't too interesting right here, the actual steps. The interesting part is this use of pivot longer. So let's just walk here. So let's look at these two separate things here. So why is this interesting and why might this only work? Why might not this work in general? Do you have any idea before I give away the answer?
I mean, I recently used pivot longer in one of my thing. So it basically like converts the existing columns to rows, which can we convert the rows to like columns. So it makes the data more simpler, I feel, simpler. And if you see the example here, can you go a little up in that character?
Yeah.
No, result, yeah. Like in the result.
Oh, the result? Yeah, sure. Let me, because it's so
One.
zoomed in, it's kind of hard
Yeah.
to.
So I can see like a name, these titles and aliases goes as a like a rows of a one particular column called names. Then it shows
Mhm.
all the values of those into like a columns, like maybe values of that particular columns, like a books, will turn into a row of that column called name. So yeah, it helps you like makes the data more simpler, like when you look at it in a glance. So yeah.
Yep. And those are those are all correct statements. And I think what's really important is when you make that pivot, what type of column is value now? They're all
List.
what? List.
Yeah.
What
And
type of data is inside of the lists?
character.
Character, right? So, but lists can technically hold what? Any combination of types that you want.
Yeah.
So this only works in this case because all of these list columns only contain character values.
Yeah.
This would not work if one of these list columns had, you know, any combination of anything other than character. Because
Okay.
if we did do a pivot like this on like a more general case,
Hmm.
and then we unnested longer again, it would still be a list column, but it would be something like, where was the example? It was,
It
here's an
will be
example that,
numbers and the characters, right?
yeah, which is interesting because it kind of breaks the norm of
Yeah.
this one right here. I think it was DF4. It breaks the norm. Is it this one? Is it this one? Yeah, it's this one here. It kind of breaks the norm because when I learned Tibbles, it was like hammered. It was always like hammered when you were learning Tibbles, this idea like every column or every element within a column in a Tibble is going to be of the same type.
Yeah.
But this kind of breaks it because it doesn't break it because everything is technically a list, but
Yeah.
it's like it's a
Separate.
list containing something else. So it just kind of it's interesting in the fact that it works here because they're all character, but like if you apply it, because lists can hold anything.
Yeah.
Like lists can hold any combination of objects. And
Yeah.
so it's just interesting to see this and this that only works in this case because everything is character in those lists, but it may not work in situations where there's more than any other character. So I thought this one was a
Yeah.
um, really interesting exercise because it really hammered home some of those things about like the design of Tibbles and list columns within Tibbles and what type of things can lists hold and so on and so forth. So
Yeah.
sorry, I keep scrolling you to death here. So me,
But how do you do like if it's like a combination of those? Like how do you tackle like because right now we are like complete characters list, right? So
hmm
if you have like any other example with maybe if one of the a row has double digit or other than like a same data type. So in that case, what we do?
that's a really good question. So let's just look here. So I mean, without having an example,
Yeah.
I mean, it would depend on what you would have. It would be very context specific. So because are you talking about list columns that every single column does have a list that contains the same type of data? Or are you talking about like a column that has a list that has multiple elements in it?
Combination. Yeah, exactly. Multiple combination. Yeah.
My, well, you would hope that you would have a named list
Yeah.
because then you could, I would assume, then you could take that named list and, pivot wider.
Mhm.
You would hope that you would have that. I mean, like, and it talks about it in the book, like if you do like the tidy models framework, so like if you ever use tidy models in its like structure and some of like the data objects that it pushes, it has a lot of list columns. And so they have a lot of named list columns, but those elements might be different. You might have data frames, parameter outputs, predictions inside of that one element within that list within a list column.
Mm.
So um, that's a great question, and I don't have an example, and I'm probably not doing it justice to explain it. But my thing would be like, hopefully you have a named list, because if you don't have a named list, it's going to be really hard to unnest it.
Yeah.
I would think. Um, that's a great question, though. That's an awesome question. I'm sure we can think of an example, but I don't have one off the top of mind. Let's see here. So this one I didn't dig too deeply into. I did it, but I don't know if I got the right answer for it, but this one, so the question was take the G, map cities, what does address components contain? I don't think I got the question, or I don't think I really understood the question of why does the length vary between rows? And it just basically says unnest it to appropriately figure it out. So, and then it gives you this hint that types always appears to contain two elements. Does unnest wider make it easier to work with an unnest longer? And I don't know if this hint really helped, but let's just take a look at it here and what I did. So this first set of code, I'm just trying to get the structure of what's in this address components. So we can start by looking at it. We unnest JSON. We get rid of the status column. Because we have an unnamed list, I decide to do unlist longer. Now we have a named list, so I'm going to go unnest wider. Okay, so we get this, and it's address components, right? So then we have address components. It's unnamed list, so we go unnest longer. And just so I can get an idea of the structure, because we get another named list, I decided to pull it and just look at the structure of it. And I did this, and I got this. Oh, I know why it's varying length now, I think. Because it does technically only have two elements within it, but those elements, this one element might vary. I'm guessing it's probably like voting block or something,
Yeah.
or like the type. So I would assume that this varies. So that's probably why it has variable length, is because these are different. This is like a categorical variable of like country, administrative area level 1, administrative level 1, 2. So I think that's probably the answer that I was looking for, but I just couldn't answer it. But I don't know. This one was, I don't know if the hint really helped me answer that question. Hint type always appears to contain two elements. Does unnest wider make it easier to work with than unnest longer? So I think I tried it with this. I think I tried to do like a pivot longer thing and it just didn't work. So I'll be honest, I don't think I clearly looked at it too deeply, but I think the answer, I think I got it answered with doing it like structure like this and looking at it and seeing like, yes, you do have two elements embedded nested within types, but this one is like a categorical variable and it changes. And so that's why you would have variable length, I think. I don't know. Do you have any input on this one?
Yeah.
Let's see, I can. It's my guess. Also, I'm looking at something else. So I think it's a list of type character. Oh, that's the. Okay, so in G map cities, what does address components contain? So I answered that question. Why does the length vary between rows? So 333. Does it vary by rows? Let's take a look. Oops. Uh, oh, oh, maybe it doesn't. No, types. Virginia, Arlington County. I'm not sure. Someone later on might need to help me with this one because I don't necessarily completely understand what's going on here. Um, maybe I just didn't dig too deeply into it because we have long name, short name, long name, short name, long name, short name. I don't know. Do you have any thoughts about this one?
I didn't understand. So yeah. So what is asking like to find the gap between which that I didn't understand. Like the length.
Yeah, so it's like, okay,
What
so let's see.
and why does the length vary between rows? Why?
Okay, well, let's get to address components. Let's just get to address components. This is what I thought it was, unless I'm missing something. It's inf. Oh, is it because of this? Is this what it's saying? Because you have 4 Houston,
Yeah.
you have 1, 2, 3, 4, 5, 6 Washington,
In New
3 New
York.
York, 4 Chicago. So is that what it's trying to say, like the varying rows?
Mm,
It's all the same because you have New York, New York, New York, Chicago, Illinois, Arlington, but Arlington, Virginia. It's Washington, you have Washington, D.C., and Washington State. Then the question is, so that's the varying. So why does the length vary between rows? Unnested appropriately to figure out. So the unnest longer, print inf. It's a named list. So then that's what I thought. Unnest. We have a name list. So that would be unnest wider. Let's do unnest wider. Address components. See minutes. It does not, and it's a name error, so we have to disambiguate it. So let's go names sep equals underscore. Mm, mm. I think this does actually help because it's telling you that it's different because you would have Texas, Washington State, Washington, United States, US. So I think it's just basically trying to show you that like once you unnest it, you start to recognize that Washington can be the state or it could be the like Washington, D.C. is I think
Yeah.
what it's trying to get at. Once you unnest the address components. Once again. Yeah, because see, you have Arlington, Texas. And what is this telling us? Arlington, US, Arlington County. I don't know. I think we spent enough time on it, but oh, unless it has something to do, I think it has something to do with like the short name because you have like Houston, Harris County, Texas.
Yeah.
So I think you have different ways to represent it. So the Google API is basically like there's different ways to represent it. Houston within Harris County, Houston within Houston, Texas, Houston in the United States, which is in the US. So that's why you have all these different representations. A city would have more of these, but a state would not, you know?
Yeah.
Does that make sense?
Yeah. Kind of. Yeah.
I think that's what it's trying to get at. I don't know. But
Yeah.
I don't know if the hint really helped me at all. So
Yeah.
I don't know. Oh, we're already 2 minutes over, so let's do this last one really quick. Okay, so rectangle, the DF column, DF row below, they represent 2 ways of encoding a data frame in JSON. So I copied these notes because it was knowing the difference between like an array in JSON is like an unnamed list. So if it's an unnamed list, it would tell us to go unnest longer. And then this one, which is an object, which is written with curly brackets,
Yep.
we would use um is like a named list. And so what we would use is then we would use unnest wider. Okay. So here's the example. Here's the JSON objects. We parse JSON from the JSON light package just to get them in. You can look at them. Here's the JSON column. Here's the JSON row, right? They look basically like lists, or JSON light basically turns them into lists. We make tibble columns, or we make them list columns within tibbles, just so that they're easier to work with. df call, df row. Starting out with df call, we can see that we have a named list. Since we have a named list, we can go unnest wider, which will result in two columns, X and Y. We talked about this. If we don't want the Cartesian product, we can go unnest longer, do it the same, CXY, and there you go. You have X, you have Y, and then you have all the values for X and Y, one being character, one being integer.
Yeah.
Make sense?
Yeah.
And then this last one, the representation df row using a JSON object. You technically have 3 rows with name lists in them. Because they're a name list, we can just use unnest wider on the JSON column. Run this, run it, same thing. Just so that I'm not crazy, I used Waldo to compare them to make sure that they're the same. And they are exactly the same. So I think what this was getting at is like when it comes to data frames and tibbles and JSON, you can either use arrays, named arrays, or objects in JSON. You just need to know once you parse that JSON and then turn it into a list column, goes back to that idea. Is it a name list? Is it an unnamed list? And then that will dictate to use unnest wider or unnest longer. So it was a fun chapter. I can honestly say that I learned a lot in this chapter, and I'm not as afraid of list columns as I have been in the past. So cool. Any other questions or anything else you want to talk about with this one?
No, that's all. Yeah, and it was like it is good actually. I learned about this investing and wider and longer. Yeah, it was good. Yeah, it is good. I like it. Yeah.
Yeah, it's like I said, it when I used to see list columns in the past, it was like, what do I do with these? But now it makes sense. Just see if it's a named list or if it's an unnamed list, and then go from there. And then you should be able to parse it. It gets a little bit wonky because when you do like JSON parsing, like as like JSON objects or like JSON data can be kind of complicated. Um, especially if it's coming from like an API. Like there's just so much nesting that happens.
Right.
It's interesting too because Big R query, they have these things called, what are they? They're repeated nested arrays or something like that. And you've seen that before. Um,
Mm.
if
I'm
you
just
just
yeah.
go ahead.
No, no, I'm getting like what you're saying in the big car query. So I've seen some functions like that. Yeah. Yeah.
So like because they're like nested repeated values, but they're like stored in an array within the value. And so if you actually like use Big R query to pull it out, it comes back as a list column. And so what I would try and do is like I would just try and write the SQL to like unparse it
Mm.
in SQL rather than like pulling it out and then parsing it using these tools. But now I feel a little bit more comfortable about being like, okay, we can use these tools. So we just pull out that whatever that data type is. I can't remember what it's called. I think it's like a repeated array or something like that. You just pull it out, comes out as a list column, and then you just parse it out in R if you want to. If you don't want to like do it database side, you could do it on the R side. So
That's true.
really,
Yeah.
really cool.
Yeah.
Uh cool. Well, that's everything.
Mm.
Just to stop. Unless you have any other questions before I hit stop.
I don't have any questions. Yeah.
All right, cool.